Hi, my name is Scott Simpson, and today I'll be talking about what a mole is and Avogadro's number. So a mole is a specific amount of items, so it's kind of like a chemist's baker's dozen. So a mole is actually equal to 6.022 times 10 to the 23rd items. Now this can be anything. You can have a mole of molecules, a mole of atoms, mole of people, things along those lines. So I'm going to draw some conclusions that we can make about a mole and some similarities between a baker's dozen and a mole. Also, it may be a good idea to review molarity if you're given the chance and how to calculate molecular weight before you continue on. All right, so we know 1 baker's dozen is equal to 13 items. So if we have 1 baker's dozen of molecules, that means we just have 13 molecules, right? It's very similar with having a mole of molecules. So if we have 1 mole of molecules, we have 6.022 times 10 to the 23rd molecules. So it's just a way to keep track of these numbers. Now, why is mole important? Well, if you look at the molecular weight of a compound, you'll notice it's in grams. But if you look on the periodic table, you'll see that it lists each element in terms of AMUs. So, molecular weight and moles. So how do we relate the two? Well, if we have 1 molecule of H2O, that's equivalent to having 18 AMU, correct? Well, if we look at 1 mole of water, that ends up being 18 grams. So you can relate molecular weight is equal to some amount of grams, we'll call them X grams, per mole. So you can use the periodic table to figure out how many grams per mole you'll have of whatever compound you're looking at. Now, how can you convert from grams to moles? Well, it'll be a good idea to review my video where I look at converting units for a better overall picture, but I'm going to go through a simple example. So let's say we have 76.2 grams of H2O. How many moles is that? So we also know that the molecular weight of H2O is 18, we're just going to say 18.0 grams per mole. All right, so we have 76.2 grams of H2O, and we want to figure out how many moles there are in 76 grams of H2O. So we can use our simple conversion of molecular weight. So we know we want to end up with moles. So moles of H2O. But in order to end up at moles, we have to cancel out our grams. So we're going to have grams of H2O. We know for every 1 mole of H2O, we have 18 grams. Let's just double check to make sure our units cancel out. We're going to get rid of grams, and we're going to end up with moles. And what this will lead us to is 4.23 moles of H2O. So that's how we can convert from grams to moles. Now what about using a balanced equation? to figure something out. So a lot of times in Gen Chem, you're given questions where you have a balanced equation and it wants to know how many moles or how many grams of products you're going to form. So let's look at the oxidation of glucose. So glucose is C6H12O6. You guys should know that from bio class or just from basic chemical formulas. It's a good molecule to know. So we react that with oxygen. We also have heat in here. What ends up happening is we have 6 moles of CO2 produced, along with 6 moles of H2O. Now this is a given equation. If you're going to have to go through and balance the equation, you should be able to do that. Now the question is, how many moles of CO2 gas are produced in the oxidation of 2 grams of glucose. And I'm going to give you the molecular weight of glucose, which is 180 grams per mole. So let's box off and surround parts of our question that we're trying to look for. So let's box off what we're trying to look for. So we're trying to look for how many moles of CO2. And what information are we given to start off with? Well, we have 2 grams of glucose. So almost all problems in general chemistry can be confronted by converting to moles. If you're going to convert to moles, you're probably halfway there to your solution. So we're given that we have 2 grams of glucose. So let's start with that. So we have 2 grams of C6H12O6. And we need to get to moles of CO2. Well, first, we can use our equation to do that, our balanced equation, but we have to convert from grams to moles. So we can use the molecular weight of this guy to figure that out. So we want grams in the bottom, moles up top. So for every 1 mole, your 180 grams C6H12O6 for every 1 mole of glucose. So when we multiply that out, what we're going to end up getting is moles of glucose. But we can take this a step further. So we want to know how many moles of CO2 we're going to produce. Using the balanced equation, we know for every 1 mole of this that we consume, we produce 6 moles of CO2. So knowing that, we have to make sure our units cancel out. So we have to have moles of glucose in the denominator. And we can use the balanced equation to get to moles of carbon dioxide. So we notice we actually have a 1 out front here, but it's not given, but it's implicit. And we have 6 moles of CO2. So for every 1 mole of glucose we consume, we produce 6 moles of CO2. So our units of moles of glucose should cancel out, and we'll end up with moles of CO2. Multiplying that all out, we end up with 0.0667 moles of CO2, which is great. Well, let's say we want to take it a step further. How many grams of carbon dioxide are produced? So we already have moles. Let's convert to grams. So the second part of the question is how many grams of CO2 are produced. And we know the molecular weight of CO2 is equal to 44 grams per mole. And that's just found by taking the molecular weight of carbon and the molecular weight of your oxygens and then summing them up. So, we know we have 0.0667 moles of CO2. And we're given our molecular weight, so we can convert from moles to grams. So for every, for every 1 mole of CO2, we have 44.0 grams. If you notice, moles of CO2 cancel out, so we're going to end up with the correct answer, which happens to be 2.93 grams of CO2. So hopefully with this short example, I've shown you how to convert from grams to moles and from moles to grams, and hopefully you have a better idea of what Avogadro's number is. And remember, Avogadro's number is nothing more than a chemist's picture does. So thank you for your time. If you have any questions or comments, please leave them below, and have an awesome